Hello and welcome to Physics Platter. Today in Physics Platter we will talk about the refraction of light. What is refraction, what are the laws of refraction, and then what is refractive index. In this discussion we will talk about these things. Okay, so all the time we have known that light travels in a straight line, right? But there is a condition. Light of course travels in a straight line as long as it travels in a single medium. Alright, as long as the light travels in a single medium of the same density, it travels in a straight line. But when the light comes through a medium and then falls on another medium, let's say this is the surface of two media. Alright, let's say in this side there is a medium of higher optical density and this side there is air, and then light travels in a straight line through the air. Then it falls on another medium of different density, in this case a higher density. What will happen to the light ray now? Okay, you can imagine it in another way, that let's say suppose you are running through a plane field. You are running in a straight line. Alright, and then suddenly you fall on another field full of knee-high water. You still want to travel in the straight line with the same speed. Can you do that? Of course you cannot go with the same pace in the knee-high water as you were doing on the plane field with the same speed. Your speed will be different in the water, right? And somehow you will bend a little bit in some way. In case of the light, let's say at this point O is the point of impact of the light ray between the two surfaces, between the two media. If we can imagine a normal, which is an imaginary line perpendicular to this surface, alright, let's say ON. Then if the light falls from the optically rarer medium, this is optically rarer medium, to an optically denser medium, then it bends from this surface and it bends towards the normal. Alright. Now what are these things, optically rarer and denser mediums? These are nothing but these actually depends on the transparency of the medium. That means how fast the light can travel. How fast the light can travel through a medium, that will decide if a medium is rarer or denser. For example, vacuum, let's say, or air are considered to be rarer mediums, as the light travels with the highest speed in these two media. And let's say glass or water, these are actually denser than the air and vacuum. So we can consider glass and water as the denser optical medium compared to the vacuum and air. Alright. Okay, so when the light travels from the rarer to the denser medium, it bends towards the normal. And this bending of light is called the refraction. Is called the refraction of light. Now this bending of light happens in different ways. When the light travels from the rarer to the denser medium, it bends towards the normal, and then when it comes from the denser to the rarer medium at the surface of the separation of two media, it bends away from the normal. Actually this property is nothing but the reversibility of light. Look at this picture. If the light travels from, let's say, point A to O, and then ON and N prime is a normal, let's say, it goes in the path O B. Alright. So light is traveling from the rarer medium AO, and then after it falls at the surface, it bends towards the OB, towards the normal, and it goes through the OB. Okay. Now if the light travel, if we just reverse the path of the light, in this case let's say BO is the incident ray, then of course the light will travel the same path OA as it was doing in the reverse process. So this is called the reversibility of light. Anyway, so bending of light happens because the speed of the light is changing in this case. Alright, remember one thing, the speed of light in the rarer medium was less than the speed of light in the denser medium, but it bends towards the normal. It says another thing. What is that thing? It says another property of light, which is light always follows the quickest path. Quickest path. In some cases, that can be the shortest one. More or less the same, shortest or quickest path. Okay. Okay, so that's a refraction of light. Let me draw another one where the light goes from the denser to the rarer medium. Let's say this is the normal, and then the light falls this way, AO, where N prime is the normal, and then it was supposed to go along this direction, but it bends away from the normal this time. When it goes from the denser to the rarer medium, the light bends away from the normal, and this bending of light from its original path is called the deviation of light, as we have discussed earlier. Okay, so this bending of light from its original path is called the deviation of light, and this is called the refraction of light. Refraction of light. Okay, now let's move on to the laws of refraction. Laws of refraction. Of course, this bending of light does not just happen out of the blue. It follows some laws. As we have seen that light also follows the laws of reflection. In case of the refraction, light also follows two laws, of which number one is the easiest one, which says that, let's say in this case AO, we know that AO is the incident ray, right? Incident ray. OB is the refracted ray, and ON or NN prime is a normal drawn on the surface. Normal drawn on the surface of the separation between the two media. So the first law says that the incident ray AO, the normal drawn on the surface ON, and the refracted ray OB all lie in the same plane. All lie in the same plane. Incident ray, the refracted ray, and the normal drawn on the surface of the separation between the two media lie on the same plane. That's the first law. Actually, this is quite obvious. First of all, if this was not the case, that all three rays or all two rays and the line, imaginary line, lie on the same plane, if this was not the case, we would not be able to apply the simple geometry to the optics as we do. All right, as I have drawn all these lines, the incident ray, the refracted ray and the normal, on the same blackboard or whatever it is, on the same screen, this is obvious that they are on the same plane. That's why I could do that, and that's why we can apply the simple geometrical theories to the optical problems. Okay, next one, the second one, which talks about the angle of incidence and the angle of refraction. Let's say I will draw another picture here. This is, let's say, AO, which is the incident ray. The light travels from medium 1 to medium 2 and it bends towards the normal, let's say. Then this angle is the angle of incidence, OB, of course, this one, N prime. Then angle AON is called the angle of incidence I, and then angle BON prime is the angle of refraction R. That means the angle made by the incident ray with the normal is called the angle of incidence. Angle made by the refracted ray with the normal is called the refracted angle of refraction. Okay, and the second law says that the sine of the angle of incidence divided by sine of angle of refraction is a constant. But when the two pairs of the media are kept constant. Now what does it mean? Let me tell you. Let's say, let me draw the surface horizontally. Let's say this is the medium 1, this is medium 2. All right, and I take a single color of light, let's say a same light, red light, let's say a laser beam, for example laser beam, of course. Let's say the laser falls in this angle and then it goes towards the normal. Okay, so O A B, this is I1, this is R1. Then again, let's say I have increased the angle of incidence this time, and then the angle of refraction would be something like this: A O B N N. This is I2, this is R2, and then again I have increased the angle of incidence further and it looks something like this. Let me draw it something like this. Then it bends towards this. Alright, so A O B N, and this time the angle of incidence is I3 and angle of refraction is R3. So what does the second law says? Second law says that because in this case the two media are still the same media and we didn't change the light, we have only changed the angle of incidence. In this case, from the second law, we can say that sine I1 divided by sine R1 equals to sine I2 divided by sine R2 equals to sine I3 divided by sine R3, and all equals to a constant. Alright, so did you understand this? The third law says that for the same pairs of medium and for the same light, the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant. Alright, and this constant is actually called the refractive index of the second medium with respect to the first medium. So sine I1 by sine R1, sine of the ratio of the sine of the angle of incidence to the sine of the angle of refraction is nothing but the refractive index of the second medium with respect to the first medium, and that is denoted as mu 1 2, where 1 is the first medium, 2 is the second medium. Alright, so this is the refractive, you can also write refractive index as Ri, refractive index. Alright, this law, the second law, is also known as Snell's law. This is also known as Snell's law. Okay, so the first law says that incident ray and refracted ray and the normal drawn on the surface lie on the same plane, and the second law says that for the same pair of two medium, and for a same light, same frequency of light, you can say, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant, and that constant is the refractive index of the second medium with respect to the first medium. Alright, now as we have said, let's talk about the refractive index a bit. Refractive index. What is refractive index, which sometimes is also denoted as Ri, and the symbol is generally written as mu. You can also write n in some books. It is also written as denoted as n. Anyway, so let's talk about the refractive index a little bit. What is refractive index? From Snell's law, of course, we have found that the refractive index is nothing but the ratio of the sine of angle of incidence to the sine of the angle of refraction. But as we know that this bending of light is happening due to the change in velocity, so this actually must have something to do with the velocity, right? So refractive index can also actually be written as the, of course, one is sine I by sine R, and then also can be written as velocity of light in the first medium to the velocity of light to the second medium. Alright, velocity of light in the first medium to the velocity of light in the second medium. Okay, if the first medium is, let's say, air or vacuum, then it becomes C by V2 or V. Okay, when the first medium is air or vacuum, then such refractive index of the second medium is called the absolute refractive index. Absolute refractive index, which is simply denoted as mu, and for a medium, mu can be denoted as C by V, velocity of light in air or vacuum to the velocity of light in that medium. Okay, now obviously you can see the higher the refractive index of a body, lower the velocity of the light in that medium. So absolute refractive index is nothing but the ratio of the velocity of light in vacuum or air to the velocity of light to in that medium. Now, when two medium are different, I mean none of them is air or vacuum. Let's say for example this can be water and this can be glass. This can be glass. Alright, and then light travels from water to glass. Okay, so in such cases where none of the media is air or vacuum, in such cases we can still find the refractive index, or simply we can still write the velocity of the light in water divided by the velocity of light in the glass as a refractive index of glass with respect to water, right, which we can write as C divided by velocity of glass divided by C divided by velocity of light in water. Can we write like that? Of course we can, because we didn't change anything except we have multiplied both the denominator and numerator by C, which gives us the absolute refractive index of glass divided by absolute refractive index of water. Glass and water. Such a refractive index where two media are different than air or vacuum is called a relative refractive index, because it is actually the ratio of two refractive indices. Alright, so don't be confused here, because the refractive index of glass with respect to water is actually the ratio of refractive index of glass or absolute refractive index of glass to the absolute refractive index of water. So that's called the relative refractive index. Alright, so that's all for today. We will see you in the next video. Till then, take care.